So this is navigation number 1, a boat whose speed is in still water is 4.5 meters per second, travels north across a river. The river current is 2.0 meters per second east. What is the velocity of the boat relative to the shore, and what heading must the boat take if it is to land directly north of its starting point? Okay, so those are two slightly different questions, but let's start with a vector diagram. So the first place I'm going to start with is by drawing the river. So our river's flowing to the east, so we'll make our river like so, and here's our starting point. And we know that the boat is going to go up like this. If the river wasn't flowing, it would go straight across and its velocity would be 4.5 meters per second. We know that that velocity is being added to by the current, which is flowing east at 2 meters per second. So we've got an eastward velocity like this at 2 meters per second. And the combined velocity of the boat, so the actual velocity of the boat, will run along this vector line. And so this is the resultant velocity for the boat. Clearly, we can solve this using Pythagorean theorem because the two vectors are perpendicular to each other. So we've got 2 squared plus 4.5 squared, and that's equal to the resultant velocity squared. So we'll pull out our calculator. So we've got a calculation, and that gives us 24.25 is equal to RV squared. So we need to take the square root of that to get the actual resultant velocity, and rounding it to 2 significant digits, it's 4.9 meters per second is the velocity of the boat relative to the shore. Now, that's the magnitude. Remember, we always have to calculate our direction. And so we're going to determine that angle. We've got the opposite side of 2 meters, the adjacent side of 4.5. So we use the tangent trig ratio. So to find our theta, we're going to take 2 over 4.5. We remove the tan function by taking the inverse tangent of both sides. So the inverse tangent of 2 over 4.5, that gives us a theta value of 23.96, which to 2 significant digits we round to 24 degrees. And so that's 24 degrees east of north. And so the velocity of the boat is 4.9 meters per second, 24 degrees east of north, or you might say down river. So that answers question A. Question B is quite a different question. So question B, again, gives us the river, and we know that the boat is going to have to head at some direction, but we want our resultant to be directly across here. So this is our resultant velocity now, rather than the velocity of the boat. The velocity of the boat goes here, and it becomes the hypotenuse. And that's how the boat is going to head that direction, and the boat in still water can only go at that velocity, and so we put it at that heading, and we know that it's going to be pushed downstream by our current of 2 meters per second. And so now we're going to find our heading. We don't need to find the magnitude of this because the question simply asks for the heading. And so all we're looking for is our angle here. Notice that again we have opposite of 2 and the adjacent, in this case our hypotenuse is 4.5. So we're going to use the sine function. So the sine of theta is equal to 2 divided by 4.5. And theta will be the inverse sine of 2 divided by 4.5. And this gives us, the inverse sine, this gives us the angle of 26 degrees. And here we would be going west of north, or 26 degrees up river.